In this section, we'll look at the knee. First, we'll look at the bones, then the knee joint and how it moves, then the muscles that move it, and lastly, the vessels and nerves. Let's see the bones, starting with the femur. We saw the proximal end of the femur in the last section. Now let's look at the distal end. The two smoothly curved surfaces are the lateral condyle and the medial condyle. The deep notch which separates them is the intercondylar notch. Above the two condyles are the epicondyles, lateral and medial. The sharp corner on the medial epicondyle is the adductor tubercle. This prominent ridge is the medial supracondylar line. This one is the lateral supracondylar line. Now we'll add the tibia and the fibula to the picture. The tibia and the fibula are fixed to each other firmly by two joints, the proximal and distal tibiofibular joints. There's almost no movement at either of these joints. Let's take a look at the proximal end of the tibia. This is the medial condyle, this is the lateral condyle. On top of the two condyles are two quite separate articular surfaces. They're much flatter than those on the femur. The rugged expanse between the articular surfaces is the interarticular area. This prominent lump on the front, the tibial tubercle, is the final insertion of the quadriceps tendon. The small facet under here is for the fibula, which we'll add. This is the head of the fibula, this is the neck. The head of the fibula is the point of attachment of a major ligament of the knee joint, as we'll see. The space on each side of the knee between the femoral condyle and the tibial condyle is occupied by a crescent-shaped piece of cartilage, a meniscus, which we'll see shortly. The space in the middle, the intercondylar notch, is occupied by the two cruciate ligaments. The intercondylar notch and its contents divide the knee joint into two almost separate halves. There's one more bone to add to the picture, the patella, or kneecap. The patella, as we'll see, is embedded within the quadriceps tendon, which comes from up here and inserts on the tibia down here on the tibial tubercle. On the back of the patella, the articular surface is divided into facets. These articulate either with the femoral condyles when the knee is flexed, or with this central articular area when it's extended. Now that we've seen the bones of the knee joint, let's see how the joint looks in the living body. In building up our picture of this quite complicated joint, there are several structures that we need to understand. First, the two joint cartilages, or menisci. Then the ligaments, the two cruciate ligaments and the two collateral ligaments. Then the patella and the quadriceps tendon on the front. And lastly, the capsule, which encloses the joint. Here are the two articular surfaces of the tibia. The two menisci sit on top of them. Here are the menisci. They're made of flexible fibrocartilage. They're shaped a little differently. The lateral one is almost a circle. The medial one is more C-shaped. In cross-section, each meniscus is thick at the outer edge and thin at the inner edge. The two ends of each meniscus are attached to the interarticular area of the tibia. The medial ones far apart, the lateral ones close together. In addition, each meniscus is attached all the way around its edge, both above and below, to the joint capsule. Here's part of the joint capsule. We'll see more of it later. The lateral meniscus is much more mobile than the medial one, partly because its two ends are attached close together, partly because of a big difference in the mobility of the joint capsule around the edge. By filling in the spaces between the femoral and tibial condyles, the menisci produce an even distribution of synovial fluid to nourish and lubricate the articular cartilage of the femur and tibia. Now let's look at the two pairs of ligaments which hold the bones together at the knee joint. The two cruciate ligaments on the inside and the two collateral ligaments on the outside. We'll look at the cruciate ligaments first. They're the important structures which prevent forward and backward movement of the femur on the tibia. Their name comes from the fact that they form a cross, like this. Here's the anterior cruciate ligament, seen from in front. Here's the posterior cruciate ligament, seen from behind. To get a better look at them, we'll remove the lateral condyle of the femur. Now we can see the whole of the anterior cruciate ligament. The anterior cruciate ligament goes from here on the tibia to here on the femur, on the inner aspect of the lateral condyle. The anterior cruciate ligament prevents the femur from moving backward in relation to the tibia. Now we'll look at the posterior cruciate ligament. We'll remove the anterior cruciate ligament to see it better. The posterior cruciate ligament goes from here on the femur to here on the back of the tibia. The posterior cruciate ligament stops the femur from moving forward on the tibia. By preventing backward and forward movement, the cruciate ligaments ensure that the condyles of the femur stay in one place as they roll on the condyles of the tibia. Without them, the femur would roll off the back of the tibia in flexion and would roll off the front of it in extension. Now let's look at the two collateral ligaments, the fibular collateral ligament on the lateral side and the tibial collateral ligament on the medial side. The tibial collateral ligament goes from the medial epicondyle of the femur to the anteromedial aspect of the proximal tibia. The tibial collateral ligament blends with the capsule of the knee joint behind and also in front. On its inner aspect, it's firmly attached to the edge of the medial meniscus, which is here. Now let's look at the rather different fibular collateral ligament. It goes from the lateral epicondyle of the tibia to the head of the fibula. The fibular collateral ligament stands out from the side of the knee joint. Unlike its tibial counterpart, it doesn't blend with the joint capsule. It's not attached to the meniscus. When the knee joint is extended, both the collateral ligaments are tight. When it's flexed, they become less tight. The function of the collateral ligaments is to keep the femoral and tibial condyles together, and thus to prevent the knee joint from bending from side to side, like this or like this. In addition to the obvious knee movements, flexion and extension, it's also possible for the tibia to rotate a little on the femur, like this. This rotation can happen only when the knee is flexed. When it's extended, the tightness of the collateral ligaments makes rotation impossible. The next structure we need to add in building up our picture of the knee joint is the quadriceps tendon, and along with it, the patella. Here's the distal end of the quadriceps muscle, which we'll see in more detail later in this section. Here's the quadriceps tendon. The patella, which is here, is enfolded within the tendon. The part of the tendon below the patella is known as the patellar ligament. On the medial side and on the lateral side, the tendon is continuous with the capsule of the knee joint. Between the quadriceps tendon and the femur is an extension of the knee joint cavity, the quadriceps bursa. It's lined with synovial membrane. This lubricated pocket enables the quadriceps tendon to slide easily on the femur. Now we'll complete our picture of the knee joint by adding the fibrous capsule which encloses it. Here's the knee joint with the joint capsule intact. On the medial side, the thin capsule is continuous with the tibial collateral ligament. But on the lateral side, the capsule is separated from the fibular collateral ligament. On the back of the joint, the capsule is thick and strong. The thickened posterior capsule prevents hyperextension of the knee joint. Here, we've divided the fibrous capsule to see its inner surface. It's lined on the inside with synovial membrane all the way around the joint, except at the back. At the back, as we'll see if we remove the capsule, the thin synovial membrane, here it is, passes forward around the cruciate ligaments, covering them on the front.